Nice to finally meet you in person, Alexandra.
Thank you, Sarah. The pleasure is all mine.
Today we are at HP Fula in Kömmerling in Pirmasens. We are Sara Liébana Viñas and Alexandra Rohr, and until a few minutes ago we were still in the production together and I learned a lot of interesting things, but more about that in a moment. Alexandra, would you like to introduce yourself and HP Fula briefly for our listeners?
Sure. My name is Alexandra Rohr. Within HP Fuller, I'm responsible for the marketing and communication activities for the business unit Insulating Glass. We, HP Fuller, are the world's largest producer of adhesives and sealants. With our innovative adhesives and sealant solutions, we deliver several markets such as electronics, hygiene, medicine, construction, transport, and renewable energy. Pirmasens site here was named as Technology Center of Excellence for Insulating Glass, which means we are responsible for the developing of new products, new markets, new applications, but also to drive forward the existing expertise. And you, Sarah?
My name is Sara, and I am in charge of the global technical marketing for the reactive sealant product group at Evonik. I am responsible for the operational and strategic development of the portfolio. With the POLYVEST team, among other teams, I work on the launch of new products, the expansion of business in the regions, and the sustainability strategy of the product group as well. We have spent the day together and you were kind enough to show me your production. In doing so, I learned a lot about how to reduce energy consumption at home while significantly reducing the CO2 footprint, especially when using insulating glass on windows.
Well, saving energy and meeting the Paris Climate Agreement are relevant to all of us. And we at HP Fuller are committed to improve our lives and protecting our planet. One of our main tasks is to supply the insulating glass market with innovative state-of-the-art solutions and thereby achieve savings in energy consumption.
Earlier today, you showed me, using the example of a sample window, why up to 50% of the heat in our home can be lost through windows and doors. This is a significant loss that we need to reduce for the sake of our planet. All homes lose some heat through their windows and doors, for sure. But the goal is to take some measures to reduce this as much as possible. I also understood that high-quality windows are an effective solution to reduce the heat that escapes through our windows. How much can we save in energy cost with a modern technology based on insulating glass?
The savings potential is different for each house, of course. Some influencing factors include the climate conditions at the location, the construction method, the used building materials, and so on. Also, the size of the house combined with the quality of the insulated glass and the entire window must be taken into account. However, it is estimated that for an average single-family home at current gas prices, a high-quality, permanently tied, double-glazed window compared to an old single-glazed window can save more than €1,000 per year in heating costs. And considering a modern high-quality insulated glass unit has a lifespan of up to 30 years, so this results in an enormous amount.
Is there any legislation or any specific building regulation requirements that must be met when choosing a window for our home and offices?
Indeed, recently the EU Commission and the European Council agreed on revisions of the Building Directive. The main objectives of the revision are, broadly speaking, all new buildings should be zero-emission buildings by 2030 and existing buildings should be upgraded or rebuilt to zero-emission buildings by 2050. And in addition to all energy-related goals, the legislation will also consider health and well-being of the building users.
By installing thermal insulated windows, not only will the energy consumption be reduced, but the CO2 emissions will also be less. The potential reduction in the carbon footprint is really huge. A research study has shown that the use of energy efficient glazing in European countries could save 100 million tons of CO2 per year. Your solutions can make a significant contribution to this, right?
Yes, that's right. One of the best ways to make a house more energy efficient is to insulate it optimally. And today's windows are designed to do exactly that. With a permanent gas-tight double or even triple glazed window, you can save several tons of CO2 per year. Significantly lower energy loss compared to a single glazed or leaking system.
You showed me earlier on a sample of a multi-glazed window before in the lab that a modern insulated glass consists of 2 or more panes of glass with a special coating and an inner gas filling inside. We also know that the longevity and the reliability of the window really relies on the quality of the sealant. At HP Fuller, you offer glass sealants for energy efficient windows. How does the sealant system work exactly?
The sealing compound holds the insulated glass units together while providing a reliable barrier against gas loss and moisture intrusion. It is called the edge seal. If this edge seal doesn't work properly, the gas which insulates can escape from between the panes to the outside and water vapor can enter into this space, which then significantly affects the insulating properties. And by the way, the same applies to sound insulation.
It's interesting that the quality of the sealant is really the guarantee of maintaining the thermal and also the acoustic insulation properties of the insulating glass. It was very interesting for me to see how the sealant is really produced. I've never seen something like that before.
Yes, because not all sealants are the same. There is a lot of know-how behind it, even if it looks unspectacular from the outside. All you can see is a black lining running around the insulated glass unit, but there's a lot more behind it. The edge seal consists of two sealing stages, the primary seal and the secondary seal. The primary seal is applied between the spacer and the glass to protect the insulating chambers from entering of water vapor and the escape of the insulating gas. It is not a structural bond and does not contribute to the stability of the insulated glass unit. The secondary seal not only bonds the panes of the insulated glass units together and provides a structural bonding of the insulated glass unit, but also seals across the spacer width. In other words, it provides structural stability and protects the primary seal from external influences such as weather or load.
I can imagine that the material properties of these two sealants differs considerably. What kind of chemistry is behind this technology?
Okay, now we're diving really deep into the chemistry. Let's give it a try. The primary sealant usually is polyisobutylene with thermoplastic properties. The secondary sealant can be made from a variety of chemistries, including polyurethanes, polysulfides, or silicon. And they must be designed in terms of mechanical properties to reliably compensate for the loads acting on the primary sealant in order to best protect it, as mentioned earlier.
How can you decide which type of secondary sealant should be used for which applications?
Well, this depends on various aspects. Silicones have high resistance to UV radiation and are often used when high weathering resistance is required. For example, in frameless glazing with long periods of direct sunlight. Polyurethane and polysulfide compounds are characterized by very good resistance, low water vapor transmission, and gas permeation rates. High quality polyurethane sealants have the lowest water vapor transmission, are flexible, and adhere to many types of surfaces such as glass, metals, or plastics.
Polyurethane chemistry is particularly interesting, especially to me. I am responsible for POLYVEST products, so I am biased. What can I say? Polyurethanes adhesives and sealants are available as one or multi-component systems, which can be elastic or rigid depending on the formulation. When glazing windows, elastic properties are crucial to compensate for deformation caused in particular for the weather changes. Is that right?
That's right. The desired physical and or mechanical properties of sealants can be achieved by adjusting the composition, such as with two-component polyurethane sealants. In these sealant compounds, two components are mixed. Component A is usually a mixture of polyols, plasticizers, fillers, and catalysts. Component B is usually an isocyanate. The properties of the sealant can be optimally adjusted through the correct ratio of all these components.
Yes, and this is where Evonik plays a role by supplying the windows industry with the best quality raw materials for their formulations. We, in the coating and adhesive business lines of Evonik, offer hydroxyl functionalized liquid polybutadiene under the brand name POLYVEST HT. This is a polyoil that can be used for the component A that you mentioned in your polyurethane sealant. Other business units supply isocyanates, for example, for the component B.
Yes, indeed. The quality of these raw materials plays a massive role in the performance of our sealants, and we are very pleased to have Evonik at our side as a supplier and business partner. In addition to the good quality of your raw materials, we appreciate your efforts in sustainable solutions, which results in a lower CO2 footprint in our formulations.
Yes, this year we have launched into the market our first product portfolio based on ISCC Plus certification scheme, because we are aware that our carbon footprint is going to be reflected completely in your carbon footprint. So if we reduce our carbon footprint, we reduce automatically yours. So as you see, we do not only talk about sustainability, but we try to do our best to really apply sustainability. It's definitely a key issue in the chemical industry, not only for Evonik, but for the whole industry. And we are really determined to help shape the future. It is also very important for us to offer even more sustainable solutions in all the markets which we operate. We have analyzed really our entire portfolio, and we classify products according to their sustainability performance, both in terms of footprint and also handprint. In the European market, so for example, POLYVEST HT for windows glazing, only for this specific application, is designated as a leader in our classification, and it is therefore considered as a next generation solution, which we are most proud of. These solutions will be the focus of the entire Evonik group in the coming years. We are very proud to support you with this product and to make our contribution to making buildings more sustainable.
And we are basically in the same boat because we, HB Fuller, are also continuously developing innovative solutions for a more sustainable future.
Well, we've learned a lot from you about insulated glass and how Evonik's adhesive and sealant solutions can help this market go beyond chemistry by effectively reducing energy loss and CO2 emissions in buildings. Now, sadly, our conversation time has come to an end. And here I would really like to thank you very much for the nice talk.
That was fun. It was a pleasure. Hope to see you soon again, Sarah.
Evonik, leading beyond chemistry.